All right, so because this can be a little bit tricky, I'm also going to leave you the video kind of with worked out solutions for finding the area. Again, just want to make sure that we get off on the right foot here. So again, your shapes all have to be regular polygons. Regular just meaning, again, same side lengths and same angles. All right, and remember that it's working because I can inscribe these guys in a circle. That's the whole idea. And when I do that, right, what I've created, right, you've got some radii that are happening. And because I've got radii, I'm splitting them into isosceles triangles. So when I drop that apothem, I'm able to cut my sides in half. Okay, so to figure out these great big angles around here, I take 360 because that's how many degrees are in a circle, and I divide by how many triangles I created, which in this case was 1, 2, 3. So it's very similar to the last one on our notes. Oh, sorry. So I'm going to divide by 3. I just got ahead of myself, and I'm going to get 120 degrees. Now, because you've dropped an apothem, sorry, I was searching for whiteout. There we go. Right, because we dropped an apothem, the idea is that's that perpendicular bisector. It's going to go ahead and split that angle in half. So if the whole thing is 120, then each piece of it is going to be a 60. Right, so 120 cut in half is going to get us a 60. And when that happens, ladies and gentlemen, you have a 30, 60, 90. Okay, so that means this angle down here is my 30. And so if we pull the triangle out, just so we can kind of see it, right, so my 60 is up here, there's your 30 degrees, here's your right angle. So again, I just kind of flip-flopped it. And then that 8.5 is pointing to the apothem, right, 8.5. It's pointing to, if we notice, it's pointing to that right angle, the side that's on that right angle. So if we think back to, again, here's my 30, 60, 90. If I use my table, across from the 30 is the x, 90 is 2x, and 60 is x root 3. So if across from my 30 is 8.5, which absolutely we can change into a fraction. Sorry, we'll make the table real quick. Okay, if I take 8.5 and we double it, that's going to get us a 17. Okay, which means that my hypotenuse over here, that's going to be a 17. Okay, and then if I want to go ahead and find my length, right, which is going to be part of that perimeter, that's whatever x is multiplied by the square root of 3. Now again, if we take 8.5 and we if we change that to a fraction, it's really going to be 17 over 2. So 17 over 2 square roots of 3. Now what we have found would be this piece right here, which I'm going to color on the triangle. It's right here. Okay, now, regardless of which formula you want to use to find the area, I really need 2 of those, right, to go the whole way across. So 17 over 2 times the square root of 3, I need that to happen twice. And how fortuitous that those 2's cancel out. So my side length is going to be 17 root 3. All right, so my area, again, you can do this however you want. I think on this one, I'll go ahead and I'll use the 1/2 times the apothem times my perimeter. So 1/2, my apothem is going to be 18.5, which is the same thing as 17 over 2. And then my perimeter is 17 square roots of 3, and that happens 3 times. All right, so recall that when we go ahead and we're going to punch that on the calculator. Okay, so again, essentially you're just going to multiply everything except that root, right? It's the same idea like when we want to leave things in terms of pi. So I would have 1/2 multiplied by 17 over 2, multiplied by 17 multiplied by 3. All right, so I could either have this, which again, I'm noticing my answer is in fraction form, so let's go ahead and change it to a fraction. So my final answer should be, in fraction form, 867 over 4. Don't forget your square root of 3. My units were inches, so inches squared, which does check on here, so we're feeling good about that. All right, so we're going to do the same thing again on number 2. So if I go ahead and create my triangle, again, my circle, right, if I were just going to sketch real quick, my circle would go around, give or take. Oh, that wasn't terrible. Which means that these would all be the same because they're radii. then one last one. That would have probably been easier to just cut them across. Okay, so I've got 6 identical triangles. So again, if I want to figure out what those top angles are, I take my whole circle, or 360 degrees, and I'm going to divide by 6. And so those angles should come out to 60 degrees, which means, right, that each piece up here, those are going to be 30 degrees. So again, if I pull that triangle out, just so we can see it, this time my 30 is up here, right at the top. This would be 60, here's your 90. And 15, right, 15 inches, that was going to be the apothem. Okay, so again, if we use our 30, 60, 90, right, so here's 30, 60, 90, x, 2x, x root 3. And this time, the 15 is across from the 60. Which means that 15 is equal to x root 3. So we've got to get the x by itself. So we're going to divide both sides by square roots of 3. Again, you are excellent algebra students, so you know you can't leave it that way. So 15 square roots of 3 multiplied by the square root of 3 over the square root of 3. 15 root 3 over 3. That can reduce, and so we're going to get a 5 root 3. That's our x. Okay, which is here. So on my picture, that's here. All I did was take that triangle and pull it out so we could see it. Okay, so if you want to find the 90, you absolutely could, right? We would just double that, would be 10 root 3, but I don't actually need it in this case. What I do need, right, is to go all the way and get the other side, right? So I need to get this side over here. So the whole length, right, would be 5 root 3 multiplied by that 2, which happens to be the 10 root 3 as well. All right, so however you want to do it at this point. So area, again, you can either do the area of each triangle. Maybe we'll do that one this time so you've seen it. So I'm noticing there are 6 triangles. So I want 6 times, and then I want the area of each triangle, which would be 1/2 times my side length, which we've just found was 10 root 3, multiplied by the apothem, which we knew was 15. So again, on our calculators, we're going to punch everything except the square root of 3. So 6 times 1/2 times 10 multiplied by 15 is going to get us 450. Keep that root 3 in there. We just don't punch it. And then this one, again, it was inches squared. So there's our area. All right, number 3. Move that down a little so you can see. Okay, so if I sketch triangles again, trying to find another color. All right, so here we go. There's a set. There's a set. There's a set. And there's a set, give or take. So again, to find the ones at the top, I go all the way around. So I take 360 and I cut by the number of triangles, which in this case there should be 8. So 360 divided by 8, which I believe we already did and got a 45. And then if we take 45 and we cut it in half, right, because remember my apothem cuts it in half, so 45 divided by 2 is going to get you, not times, should be that 22.5. All right, so each one of those little angles, that's going to be 22.5. So again, if I kind of pull the triangle out, I appreciate it's upside down, but it doesn't really matter. But here, just so we kind of see it. So if I pull it out just so we can see, there's the right angle, 17 was here, and this angle right here was 22.5. And what I need, okay, because they gave me the apothem, I need to figure out that base, right? So I need this piece over here. Now, again, this one is not going to be a special right triangle. I don't have 30, 60, 90. I don't have the 45, 45, 90. So I'm going to have to go ahead and use trigonometry. You've got a side that touches. This side would be adjacent. This side doesn't. This would be opposite, which means you're looking at a tangent function. So tangent of 22.5 is equal to opposite over adjacent. To get that x by itself, we'll go ahead and multiply both sides by 17. It's going to get rid of that. So again, on our calculators, we've got 17 tangent 22.5 should come out to 7 point, what are we rounding to? Tenths. I might keep it out just so we've got it. So 7.04, I might go 2 just to keep it. That's going to be our x, right? That's going to be your side length. Because again, we don't want to round to the end. So I'm going to just kind of keep it on the calculator. Now again, as we've talked about, the x is only part way, right? It's only half of the distance. So I really want to double that. So again, on the calculator, I'm just going to hit times 2, and that way I don't have rounding issues. So my side is going to be 14.08 and change. All right, so my area, again, you can use either formula. This time I might go ahead and just use the apothem and the perimeter. So 1/2, my apothem is 17, and my perimeter is going to be all those sides, so 14.08 multiplied by, and then there should be 8. Okay, so because I already have that, right, we're just going to do times 8 times 17 times 1/2. And then rounded to the tenths, that should get us at 957. So again, if we rounded too early, you're not going to get quite the same answer that I am. So you want to be careful, especially, again, the pre-AP curriculum, they expect for you to be able to use these calculators to hold those decimals and keep going. All right, so 957.7, again, this is also inches squared. Okay, and then last but not least, we have number 4. Very similar to number 1, right? You know it's going to be an equilateral triangle. Sorry, we'll switch to orange because we've done this one a couple times now, right? So we know that each one of these angles, the whole thing is going to be a 120, and then if we cut it, this is going to be a 60. That's what we know. Again, just because we've done it a couple times now. So here's your right angle. Again, if I pull that triangle out just so it's a little bit bigger so we can see. All right, here's 60, here's 30, and this time, if my perimeter is 18, right, that means that each side would be 18, divided by 3. So each one of my sides is going to come out to 6. And then remember that 6 cut in half, right, is going to get me this piece. So across to my 60 is a 3. So again, if we use our table, here's your 30, 60, and 90. X, 2x, x root 3. 60 is going to be a 3. So to find x, right, we take 3 equal to x root 3, and then we're going to divide. But you are an excellent algebra student, and so again, we're going to multiply by that root 3 to get rid of it. So I'm going to get 3 root 3 over 3. So your x is just going to be a root 3. All right, so that's across from our 30. That's going to be your apothem, right? That's the piece that just comes down. So my area, right, 1/2. Again, they gave me a perimeter, so I'm probably just going to use that formula since it's already done. So 1/2 multiplied by the square root of 3, that was my apothem. Perimeter was already done. That was an 18. Half of 18 would get you a 9, so 9 root 3, this time it's kilometers squared. And hopefully that's starting to make a little bit more sense to you.